Okay, wonderful people, let's continue. We are now in 2.2. Simplify each of the following algebraic expressions. We have 3m plus n squared, 3m squared plus mn squared plus 3mn minus m minus 3n divided by m squared minus mn minus 6n squared. Right, this is what we have, and in this that we have, we want to simplify this. Now the best of what we can do is to try and look for something that is common. That is mainly what we do here. Right, let me check if I've copied everything correctly. This is 3m squared, mn squared. Oh, there's something missing here. Jesus. Sorry, 2.2, 3m n squared, 3m squared plus mn squared plus 3mn plus n3 minus m minus 3n m squared minus mn minus 6n squared. Right, and what we can do from here is to try and look for something common. So we have 3m plus n squared. Nothing is common on the numerator. Let's check in here. Something, let's say something is common here, and see what we can get from here. Let's say it's m to the exponent of 1. So let's say m into 3m plus n squared. Is this correct? Yes. This times this is this times this is that. Right, let's say plus. Again, let's say something is common here, which is n, 3m plus n squared. Can you see that? Even here we have n that is common. Multiply this, multiply that. Right, from here we can continue. Minus m minus 3n, because there's nothing common there. But in here, m squared minus mn minus 6n squared, it looks like a difference of 2 squares, and 3n positive, negative, and this works exactly the way it should. Sorry, this is 2, not 3, so this is 2n. Right, and then when we multiply here, m squared, this would be minus 2n plus this would be minus 2mn plus 3mn. We need to find a negative, so this has to be negative and this has to be positive. Let me just rewrite this. 3m plus n squared, there's something common in here which is the same as there, that is 3m plus n squared, and then we insert this inside of the brackets. Very good. Minus, here we have m minus 3n, and then remember, I'm just rewriting this as m minus 3n as m plus 2n. Let's check if this is true. M squared plus 2mn minus 3mn, that would be minus mn minus 6n squared. So we are very correct here. Now, what is it that I can do from here? Let me check what I can do from here. From here, I think I can take out an LCD. I think I can do that. my LCD would be m minus 3n, m plus 2n, 3m plus n squared plus m plus n. Can you see that here? There's nothing I can do to simplify this. I cannot do anything in this and even that. But check what is happening there. I want to draw your attention. This is the numerator and this is the denominator. Can you see that? Right. And then I have 3m plus n squared. Look, 3m plus n squared, 3m plus n squared. Can you see what I have there? Now I have a 1 divided by m plus n minus 1 over, remember you have cancelled, m plus 2n. This is what I get. And the LCD there will be m plus n, m plus 2n. And you would get m plus 2n minus into m plus n. Why? This into this goes once, this times that is this, subtraction sign. This into this goes once, this times this is this. Therefore you can have m plus 2n minus m minus n. If you remove the brackets by multiplication, m plus n, m plus 2n. Now look what is happening. Positive and negative, they will cancel. 2n minus n is n. N divided by m plus n into m plus 2n as your final answer. You need to work on that for quite some time. 2.2.2, we have x squared minus 8x plus 16 divided by 6x plus 3 multiply by 4x squared minus 1, x minus 4 times 5x minus 5 divided by x squared minus 5x plus 4. So this is what we have. I think I can factorize this. Factorizing that would give me the following. The factors of 16 that can give me 8, 4 and 4. X, 4 and 4, and they must both be negative. Minus 4 times minus 4 is 16, minus 4 minus 4 is minus 8. Good. There's a common factor of 3 there. 2x plus 1. 6x plus 3 times. This is a difference of 2 squares. 2x plus 1, 2x minus 1. Very good. X minus 4 times. There's a common factor of 5 then. X minus 1. I can factorize this. X, 4 and 1, and they must both be negative. This time this is this, minus 4 minus 1 is minus 5. Good. Denominator, numerator goes out. Numerator, denominator goes out. Denominator, numerator goes out. Numerator, denominator goes out. What am I left with? I'm left with 2x minus 1 divided by 3. Is there any other thing that I have left? No. This is my final answer. You need to be very careful there. We are dealing with N2 mathematics here. Right. Let us continue and now move to question 3, because that's exactly what we are heading for. Solve for r in the equation 3.1. We have 3 exponent r. 1 minus 1 divided by 9 equals 24. I can simplify this and find what the answer would be. So that is to say 1 minus 1 over 9. And you would get 8 over 9. So 8 over 9, 24. 8 over 9, 8 over 9. 24 divided by 8 over 9. 24 divided by 8 over 9. And that should give you 27. Are we fine? We can write 27 as 3. When the bases are the same, we equate. Our r is equals to 3. Right, it's rainy outside. I'm trying to be as quick as possible. Right, without using a calculator, show that log of subscript base this is 5 divided by 4. 3 marks are provided for this. What we can do, we should show that the left is equals to the right. That is fine. We can say log 16. This is the same as 2. I think it's exponent 5. But let me just verify. 32 equals shift fact. Yes, that's exactly how it is. Now I can take this to the other side. Now I want you to check something here. We need to use the change of base theorem here. We need to say log 2 to power 5 divided by log 16. This is exactly how we do it. Take to the other side, we would have 5 log 2 log 16. It's 2 to power 4. I think so. Yes, and then you will have 5 log 2. Take this to the other side so that you have 4 log 2. Look what is happening. 5 over 4. Therefore left hand side, right hand side. In the basic simple things. This is a grade 5, grade 6 mathematics. Right, but such problems can be asked in N2 engineering mathematics, which is equivalent to grade 11, of course. So we can go to 3.3, but a grade 5 learner, grade 6 can solve this. My students can solve this. 3.3, use exponential laws to simplify the following. 2n minus 2n plus 2 divided by 2n plus 3. This is a grade 10, grade 9 problem. Now we can say this. Remember, when you multiply, you add. 2n to 3. Remember, when you multiply, you add. Very good. There's something common in these, which is this. 1 minus 2, 2n to 3. This into this would go once. 1 minus 4 is minus 3 over 8. Very good. Now write the following as a single logarithm. We have a 3 log 2p minus 4 log 2p, q minus 5 log 2r. I'm going to bring this here. Log 2p3 minus log 2r4 minus log 2r5. Remember, I'm bringing this here, there, and so on. I know that when I subtract, I divide. So what I would have is log 2, then I would say p3 divided by r4 divided by r5. This is what I would get. Right, if that be exactly that, sorry, this is Q. Ish, Jesus, this is Q. I'm sorry, this is Q. It's PQR. And then from here, what is it that I can do? I can choose to leave it like this because there's nothing I can do with these, but I can yeah, I think I can just leave it like this, unless I want to change division to multiplication here, just to say log 2. And what I would say is the following. I can say remember, I'm having P3. I can change this to multiplication, and this becomes 1 over Q4 and 1 over R5, which would then be log 2. And then what I can do there, check, I can say this times this times this is P3 over Q4 R5. Can you see that? Because I know when I change division to multiplication here, they will swap. Division to multiplication, they will swap. So you will end up with something like this. You will end up with something like this, if this is making any sense to you. Or you can even leave it like that. But somebody will look for the memorandum for us. We unfortunately don't have it. Let's go to question 4. In question 4, something very interesting is happening. And before I go to question 4, let me just have a drink.